This lecture will cover formal charge. We'll define and calculate formal charge for Lewis structures, and then we will pick the best Lewis structure using formal charge. Formal charge is a way of distinguishing between different possible Lewis structures to decide on the most probable one. We'll start with an easy example and calculate formal charge on each element in carbon monoxide. Two things you should know about formal charge. For each element on the compound, the charge should sum up to the charge on the compound. So in this case, carbon monoxide has 0 charge. So if you add the charge from carbon and from oxygen, it should equal 0. The smallest possible formal charge is preferred. So if you have multiple different possible configurations, you go with the one that has the lowest formal charge for each element. All right, so here is our equation. Formal charge is equal to the number of valence electrons, and that's on the element, minus the number of unshared electrons, meaning not bonded, plus 1/2 the number of electrons in bonding pairs. And I have put in red here the fact that there is a parentheses around the unshared electrons plus the electrons in bonding pairs. Those are all going to be subtracted off from the valence electrons. So let's try this for carbon monoxide. We'll start with carbon. Carbon has 4 valence electrons. There are 2 unshared electrons, and we want to take 1/2 of the 6 that are in bonds. So that gives us a total of -1. Okay, so carbon's at -1. And then we can do oxygen. So we have 6 minus the 2 minus 3, and we get +1. If you add -1 and +1 together, you get 0. Okay, so we have just calculated the formal charge on carbon monoxide. Sorry. All right, let's try to decide between two possible representations of silicon dioxide. So we have one where we have double bonds on both sides of the silicon, and one where we have a triple bond and a single bond. Now, I like to make tables to help me organize information like this, because otherwise it gets a little bit overwhelming. But we're going to use that equation that we have on the top right corner. So the number of valence electrons is the number of valence electrons on the element. The number of unshared electrons is just things that are not bonded, and the number of bonded electrons obviously is how many electrons you have in bonds, and then you're going to do the equation. Please take a moment to fill in the table for yourself, and the answer will be on the next slide. Okay, so when we do these calculations, we find that the formal charge when we have double bonded oxygen is 0 for every single element. If we have a triple bond and then a single bond, we have a +1 on the triple bonded oxygen and a -1 on the single bonded oxygen. So the preferred configuration is the one where you have double bonds. All right, so formal charge is equal to the number of valence electrons minus the number of unshared electrons plus 1/2 the number of electrons in bonding pairs. And you're subtracting off all the stuff that is unshared or bonded. Formal charge on each element in a compound should add up to the charge on the compound, and the most stable configuration generally has the lowest formal charge. Now I say generally because there are some weird exceptions, and we will probably encounter them at some point in this unit, but we will not get into it until we see them.